down. So breathe. I've got 53 slides and what, 20 minutes? We can do this. We can so do this. Alrighty. So today, guys, I'm presenting my work for the last couple of months. It's a little project called TAO TK. Like most of these go, it's about 10% of the really cool stuff and 90% of, there's a lot of code. The key features, this has basically been my personal spell book as far as putting projects together. So it's turned into like an object architecture with all the nifty things that I need to do, very big projects. I've introduced the idea of property inheritance to TICL TICL now has option handling, notification handling, a mega widget toolkit, an SQLite backend for the properties, and method ensembles. All of them done half-assed and at great expense, but they're done. Okay, and I've also introduced the concept of class method inheritance. You know, we all have that, well, okay. Those of us who play with TICL, we always have that method that we put inside the class itself, but it's so annoying that it just doesn't follow. I fixed that. Oh, no, you go that way, Sean. Okay, so the concept with TAO TK is very similar to a concept I had about 6 years ago before we had TICL. But I don't actually let TICL see the code directly. I run it through a parser first. And the TAO parser digests what it, basically it sends what it can directly to TICL. And then all of my extra keywords get processed up into an SQLite database. And after we get to the end of the user's block of code, we take all of the meta information we've digested and create a few extra methods that, we're pretty sure that's what the user really meant to do. All the code ultimately becomes TICL code. So you can take a TAO TK object and inherit it into a TICL object, or vice versa. A TAO object will happily inherit from a standard TICL object. And it tries very hard to mimic TICL's notation, except of course where it has to add its own little special sauce. So, as you can see, this is a definition for a very simple object. You'll note, though, that it does not have a create in front of it. That is because, slide, TAO class is actually a procedure. And what it does is it says, okay, have I seen this class before? No? Okay, I'll run OO class create. If not, I'll just run OO define. But inside that code, you can basically, if you're familiar with TICL, TAO TK looks just like it. It takes methods the same way, you specify superclasses the same way. But the value-added proposition here is that it gives you extra keywords, in particular property, and options, and signals, and variables, and class methods. And if I pace myself, we'll get to all of them. So, I think everybody's a bit tired of me talking about properties, but here we go again. Why are properties so important? Well, to me, I think of them as chunks of data that get passed along with the class. And, they're normally constant strings, but they can be other things. I won't go into it in the presentation, but I do go into it in the paper. I track them in SQLite, and what I do is I assemble them all together at the end. And I provide several methods that allow you to introspect into these properties, either from the class itself, or once you've instantiated it as an object, there's an identical property method which gives you even more properties. It's so important because I found out that options, when you define them, inherit, basically you want to track them the same way as options, And then I also do a neat thing that lets you instantiate the default value for variables. So real quick, let's say we're making a catalog of the animal kingdom. And at the very basic level, we know that all animals eat something. We don't know what it is, so for our base class animal, it's null. So we have a tetrapod. And tetrapods have a spine and 4 limbs, but you can see that it remembers that it's an animal from the superclass, and that carries through. When we define what a mammal is, well, we know a mammal is a tetrapod with a high metabolism and a 4-chambered heart. And as we get more and more detailed classes, all of the properties from the more primitive classes follow through. So we still don't know what it eats, but we remember it has a spine, and it has 4 limbs, and it's got a high metabolism and a 4-chambered heart. Come on. And then, a lot of the pets we have these days are carnivores, but we do know what carnivores eat. And, most of the carnivores we deal with on a day-to-day basis are mammals. Oh wait, no, class Carnivora is an order of Mammalia. And we know that a cat is a carnivore, but by simply inheriting carnivore, it gets all of the other properties. We don't have to remember where it came from. There it is. We can also define a bear. And then we can even handle bizarre cases like the panda, which is a bear, but it went back to being an herbivore. Okay, options. What I've done is, basically it's a special type of property, but instead of giving it a string value, you give it a key value list that describes how you want Tickle and TK to handle it. So there are keywords to specify what widget you'd like to see, what the default value you'd like to see. When somebody clicks on it, do you want it to run a script? When it retrieves a value, you want to get a script. I go more in depth into it in the paper. And then we have signals. They're very, very important when you get into mega widgets because there's a lot of times where you need to break up the life cycle of an object into chunks. In our application, we have times where we repaint the screen versus redrawing the screen versus changing the zoom on the canvas, which means that we have to redraw and repaint. So being able to specify, I just need you to run these steps, is what the signal handler does. They're basically little code snippets. The example I like to give is, let's say we're implementing a fisherman, and a fisherman can fish or cut bait. Can't do both at the same time. But we want him to cut bait before he fishes. And so if we were doing it in signals, we can specify, okay, when you fish, that operation follows cut bait, and we can even make sure that when you call signal fish, it triggers cut bait to occur. So if we're out on our command line, we create a fisherman, and we send him the signal fish. And we can see that, okay, he cuts bait, and then he fishes. And if we send the signal multiple times before update happens, we can see that in the end, he only cuts bait and fishes once, which is very, very, very nice if you're trying to update 4,000 or 5,000 objects on the screen. Class method, I was talking about before. It just gives you that what you always wanted. I want to put a class in the method. I want to put a method in the class itself and have that inherited along with. It's great if you've got an unknown handler or something that's really exotic, but you don't want to have to sit there and copy it into every single class. They inherit the same way as, basically using the same rules that you would expect a object instance method to follow along. And then, I don't know what I was thinking, but I have a keyword called variable, which does something completely different than what TickleOO does. In TAO TK, it defines what you'd like the default variable to be after the constructor finishes. But I really should call it something else because TickleOO already has a variable keyword. We'll take that discussion offline. Now, I don't know if you guys run into this often when you've got very large and complicated objects, but you mistype something and there's an entire screen full of, did you mean repaint underbar? And you know, there's 8,000 little public procedures that you didn't need to break it up that way, but you don't have to read it that way. Well, method ensembles allow you to nest them together. So we can define hello, colon, colon, world. What the user would call is hello, with world as the first argument, and then the body would call. And then I have some nifty magic that allows you to even give it arguments. And then if I define hello, kitty, that would give you a completely different behavior. The neat part is that if your descendants go off and define a new version of one of the sub-methods, only the sub-method they modified is reflected, so you can, the paper explains more. If we introspect, you can see, oh wait, even though we're using TAO TK, all the info stuff still works. This is an example of one of the dynamic methods we create. After we parse it, we also go in and define, in this case, the hello method. And you can see it inside really it's just a switch, and it's switching in between all of the implementations it cataloged for you. So, and then it also adds an extra one, bracket list, which tells you all the ones that are valid. If you give it a default, you can handle unknown cases. And then we're on to the mother of all classes. I found it handy to be able to do a lot of these policies, to have one class that I can count on all of the objects inheriting. When you get into mega widgets, you often have to remember, okay, I need to be able to operate as a tickle object, and I also need to be able to operate as a widget. Sometimes you have a database channel. There's a couple of different ways that the different object systems do it. The one I came up with is somewhere between, pretending you're really it, and just delegating methods. What I do is I simply take. Okay, I'm going to show you the example. So let's say we need to create a SQLite database that we want to respond. Basically we want to manipulate. So we basically define DB. We go ahead and have SQLite create it, and then the operation we have is called graph. What it will do is we'll use forward to make DB from here on out look like a method. So we can go ahead and you'll see, method create DB, it calls my DB just like it was a local method. It doesn't know that it's talking to an SQLite database, possibly working in a completely different namespace. And you can see, okay, using the forward mechanism inside of tickle.oo, that's what's really going on, is once you get to the MyDB part, it's the same as if you've gone out, grabbed the SQLite channel, and all the commands afterwards follow along, which is really, really helpful when you're doing things like eval here, because if you're not careful about what context you're in, you're going to get different results. This one ensures that when eval runs, it's actually running inside of this spot in the stack where your method is being evaluated. With mega widgets, a lot of times you find that it's really great that I can refer to, in this particular example, we've got, let's say we're wrapping around a text widget. So we create a text widget, and we graph the text widget as text widget. And we have a simple function that says, okay, go to the text widget, and in this case, dump all the text. Okay, that's pretty cute. But when you go to bind it, you need that path back. So the other part of the graph mechanism is the ability to look up what is that method pointed to. So here we can ask it, okay, what organ is text widget? And it gives us back the TK path we graphed it. Now, so, mega widgets are most of the reason why we have put in all these mechanisms up until now. So this is kind of a show and tell in some of the stuff that I've implemented so far. There's basically 3 different types of mega widgets. I have meta classes, which are chunks of widgets, but they're not finished yet. So, say you're implementing a command line, these are all the abstract things that you have to deal with before you actually bolt it into an actual TK widget that you are actually putting bondings on. Just common behaviors that you'd like to be able to inherit without adding extra baggage. I have what I call the classes ready to use. They're classes that sit out in a namespace that look and respond like you'd expect a TK widget to do. I.e., you feed it a TK path and it will create a TK object. And then I have dynamic GUI magic, which I use to produce a lot of displays. It's a specially formatted, basically it's a special template that as long as you know you're going to be working with fields within an array, and you give it a key value dig to describe it, it can automatically produce the UI widgets and give you all those really nice, okay, hit the font button, hit the... So, let's... what I'm going to show off first is an interactive tickle console. The interactive tickle console is actually a combination of a ready-to-use widget, a top level, and a meta widget, the meta console. And I finally combined it into a ready-to-use widget, TAO TK console. So all the user has to do is call out TAO TK console, and boom, up pops the console box, like such. Oh, no. I don't think I thought this kind of plan all the way through.
It's visually stunning.
Oh yes, the depth of space. Oh, come on. Now, let's overrun this window. All right, so we've got the console here. Oh, this is me cleaning up a regression test, but this is that console I was talking about, but I can go ahead and create another one. And over here is another standalone Topo TK window. Yay! The code to do it is this. With the right, because all the hard part's done by the meta class, when you finally get down to stitching together your own widgets, it's just block it here, and a little bit of connecting code. The paper does a much better job, largely because I'm not totally fumbling over words, because I just had a couple of days to tap it out there. I've got about a minute and a half left. Does anybody have any questions?
Sean?
Yeah.
You guys go 3:30.
Oh, you're kidding. Oh, okay, cool. Okay, so I got till 3:30. Who wants to see some more demos? Alrighty. Now, I was talking about this concept where, okay, I can combine a bunch of these meta classes into something that does something a bit more involved. And so, if you're implementing an SQLite console, most of the hard part's already been done for you as far as handling interactive commands by the console. All I need to do is teach it what's different about when I process SQLite commands. So the code to do that, is stay put, is here. So the SQLite console, what I do is I basically hijack the do command which is what, basically it's telling it, okay, I'm going to do something interactively. And instead of responding as the way TK would, pass it out to eval, it digs through and figures out, okay, I am pretending to be an SQLite console. I want to provide an implementation for the .mode. I want to provide an implementation for the .exit. And then when somebody gives me a query, I want to take that result and spit it back. So, and that console it's right here. Neat thing with the SQLite console is that you can pass in which SQLite console you want to do from the command line as an option. I specified that option right here. Option DB. So that goes in when you create the object. God, I wish I could sit down. Actually, I'm going to take 1 second here, guys, and mirror the display, just so that I can see what's going on behind me. Oh, right, good. Okay. So, if I'm working from an interactive command line, and then, tools to show. So let's just go ahead and say, can I boost that font? No, okay. Actually, I can. Okay, I'm going to put this down and try to speak up. Can you guys still hear me? No, you can't.
Yeah.
All right. So, TAO, can anybody read that?
No? Can't read it either.
Self? Console? Ah, perfect. Dot console. I'm about to just configure this console to make the font bigger. Let's say times 20. Oh, that did nothing. I'm just going to use the display. Yeah, that's it.
Is it font or dash font?
Well, that's the neat thing. There's a mechanism. You can either put it in as font or dash font, or if you just give it a list, a key value list, it just assumes, oh, that's what you meant. All right. Is that at least semi-legible to those in the front?
I can see it. Yeah.
Okay. So I'm going to do SQL console. Oh, that's I checked out SQL console. So I just give it a path. I'll call it .town, and I'm going to tell it -db. Town db. Would help if I spelled TAO right. It's not like I'm the author. Okay. So here we go. If I wanted to get really nasty, I could even tell it -TAO configure DB, and you know what? I'll have it use the main database. And magically out from underneath it, it's actually looking at a different database entirely. What you're seeing here is the options, because I noticed that they were very repetitive. Well, one of the keywords you can give it is a class of objects. And so I've already predefined an option class for organ, where I know that that's going to be something that basically is going to come in as an option, but I'm really going to turn it into an organ. So if I ask TAO TBA, what are you actually talking to? TAO. Now you notice, guys, I'm actually addressing this as like it was the TK object. cget db. Or if I do organ db, and that's because when you specify class grafting, it knows that it's not actually storing that value. It's always going to be using, when you set it, it's going to be grafting it in, and when you query it, it's going to be using the organ method to figure out where that's really going. Now it does have, now the property command will give you a list of everything that you've defined about this. So if I ask it, okay, give me a option list, I know that, okay, I have defined color state, database, font, parent window, prompt, row, style sheet, title, trace, and window style for this one.
Includes everything here.
Yes. So you notice that we have default, okay, I should just abandon, you notice from my vocabulary. So the DB prompt and title are defined up here in TAO-TK SQL console. But we don't actually start using them until we've gone off and defined a TAO-TK console. And then if we replaced it with a newer definition inside of this class, it's the newer definition that would be the one that would show up. Questions, dares? Yes?
How does this relate to 8.6?
Okay, it uses TICLO built into 8.6. It's kind of dependent on 8.6 because I do it, and despite my best judgment, I do use a lot of the L-sort dash strides and things of that sort that were introduced with TICL 8.6. But having the TICLO built in, and you can call on it on command, was kind of useful. In some of my more esoteric applications, we do use coroutines, but that's not part and parcel with the main TAO-TK spec.
Basically, you can't run it in 8.5 or 8.4 at this point.
You could run it in 8.5 and 8. You could run it in 8.5. I would have to go in and just clean up the spots where there's TICL 8.6 isms. So the new L-sort arguments are the ones that mostly trip it up. The only other requirement right now is having an SQLite, which you can count on most battery-included installations, but when I tried to make this into a kit builder, I had the neat problem of, okay, I need SQLite to build TICL. I need TICL to build SQLite. And so I had to actually dump it out to a shell script to give me the first principal builds, and then once I had that, I could use TAO to piggyback the rest. Oh, no problem. I'm actually thinking I could get away with, if you don't need the introspection, tracking the properties in the TK option database. While I was prototyping, it was really helpful to be able to dig into the SQL tables and figure out what's going on. But now that I've got all the algorithms figured out, and it's just I'm basically using it as a place to store dicks. I don't really need it to store dicks. The first couple of versions were just, okay, I'm going to write this global variable that catalogs everything. We could go back to that if you needed. And actually, when I am planning on putting this inside a TICLlib and TKlib, and when I do that, I'm going to have to address those issues so that people in A5 can use it.
You said there's a TAO TK parser involved in this. Is that something that's run in a separate pass, or is that something that is incorporated into the application sort of run on demand?
It's run on demand. What happens is when you call the TAO class procedure, it runs through your definition, and then after it's parsed through your string buffer, then it runs I'm going to build the dynamic methods, and so by the time it returns, it's already had its way with the system. And yes? Oh, no, I was going to say, there is a cleanup script in there, so that if you have modified an existing class, it can figure out, depending, by your inheritance, which other classes need their dynamic methods updated, and by the time the procedure returns, it's also updated them as well.
Architecturally, how does this compare to SNIT?
Oh, well, because it's really just a lazy man's way of producing good TICLO code. So I guess SNIT is...
This is SNIT for TICLO.
Yeah.
Except, of course, since I didn't come up with the API, I keep seeing things I want to change.
Okay, we will be selling tickets to tonight's event. We'll be putting them in the back of the room.
Cage match!
Sean, I'm sorry, but...
Okay, great guys, I will be back tomorrow. Don't forget to tip your waitress and try the veal.